Okay, this is stuff that really isn't on the exams per se. It's just kind of going over uh, microprocessors and a little bit how they're used today. They're in a lot of the stuff embedded um, that you may use without knowing there's a microprocessor in there. Um, if you were use something like a hotspot to do any of the digital voice, uh, the hotspot is going to have a usually some form of Raspberry Pi microprocessor in it that's doing the computing. Um, some of the little QRP radios that are SDR will have uh, a Raspberry Pi doing the processing. I have one, so it doesn't require a computer. It's built in. So this is just kind of give you an overview of microprocessors and some of that stuff. It probably will start showing up on some of the exams in the future, I would think. So basically, you have the most popular ones is the Arduino family, which is some outfit in Italy. The Raspberry Pi family, which is the United Kingdom. The BeagleBone, which is US Texas Instruments. And there's a lot of variations of each of those, and then there's some newer stuff. Um, there's Tiny something and ESP32, and those are mostly small for more embedded stuff, more like Arduinos. Raspbian is the version of Linux, uh, Debian Linux, that's uh, essentially compiled for the Raspberry Pi, and we'll talk about that a little bit because it's easier to set up the Raspberry Pi here than it is a BeagleBone or an Arduino. A little bit about Linux commands, a little Python, and hopefully a little demonstration of how to access general purpose input output on a Raspberry Pi Pico. So the basic Arduino uh, initial start off with the Arduino Uno. There's a lot of uh, follow-ons that are more powerful versions. There's a Duo and there's I can't remember the names, at Megas, and must be 4 or 5 different ones. And they even have some smaller ones similar to the Raspberry Pico. There's a Feather, which is a very small one. They consist of uh, usually have a USB port, a way to power it up, which may or may not be through the USB. They have breakout pins so you can manipulate through the software these input and output pins to control things. They'll usually have a couple analog to digital converters. They might have a digital to analog converter. And that's pretty much what you would see. Oh, a serial input output for a serial connection, like if you wanted to do an old RS-232 serial connection, you can do that with these. Uh, this is part of the family. The Uno was the first one. The Nano, which is sort of equivalent to the Raspberry Pi Pico. The Dewey, which is, I'm not sure Dewey is the same as Duo or Dual, but I don't, my Italian is not. But it's a little bit faster, more powerful processor. And then the Mega 2560, you see those in more things like 3D printers as a controller, some very small CNC machines, things like that, where it control hardware. And you need the extra, a little more processing power than what you'd get with an Uno. And these things are all relatively cheap. Not sure what Uno's going for today, but probably under 20 bucks. Nanos are probably under 10. They have things we call shields, and each one of these families has a different name for a plug-on board. In the case of Arduinos, they call them shields. And you can get a motor shield, which lets you directly control DC and stepping motors. There's this 9-axis motion shield, which has a built-in accelerometer and gyroscopes. You can use it for things like, remember the, what was the thing everybody used to ride years ago?
Merry-go-round.
No, the vertical.
Oh, you were a pole dancer?
No. Oh, what was that? You know, you just stand on it, it's got 2 wheels, and you lean forward, go whatever, yeah. You do one of these to control something like that, okay? Detect its acceleration and with the gyroscope. So you could, in one of these, and that may be what they actually use, I'm not sure. There's Ethernet, because the smaller ones don't have a built-in Ethernet. So you can add that. There's relay shields, so you can control all kinds of relays to control power things. And there's dozens of shields. Then we get to the Raspberry Pi family. The Raspberry Pi is a little more powerful, at least the basic one, than the Arduinos. And it's more like a well, it's a single board computer. It has wireless, it has Ethernet, it has USB ports, it has HDMI ports, it has audio, it has a camera connection. I mean, it has everything you need for a complete computer. You just attach a USB keyboard and mouse and a display, and that's all you need. This one is showing a Model 4, which has been replaced with the Pi 5, which are now available. And they're running 80 bucks. Well, it depends. The 8 megabyte version is 80 bucks. Or 8 gigabyte version.
More powerful than what they have on the shelf.
Oh, hell, my watch is. But yes. And like the Pi 5 is essentially twice as fast as the 4 in the tests. Oh, okay, let's see. Is there anything I miss on there? And these are very small, by the way, probably 2 by 3, somewhere in that range, inches. Part of the family is the smallest one so far is the Pico, and I have one of those here. We'll try to fire up in a bit. Then the Pi Zero, they've come out with the Pi Zero 2, which is twice as fast as the Pi Zero, and this comes in a wireless or a non-wireless version, depending on what you need. This is typically what you would see in a hotspot. Then the Raspberry Pi 4, now the Raspberry Pi 5. And then there's a Raspberry Pi, and I forgot to bring it, 400, which is a similar processor and it's embedded in a keyboard. So it's basically a complete computer in the keyboard. All you need is a mouse and a display to hook up to it. Like I said, they all have attachments. In the case of Raspberry, they call them hats. In most cases. Now, you also see Pi plates and some other Pi related things, but again, you can get stepper motor hats, and to drive stepper motors, there's some that'll drive regular DC motors, pan and tilt for like controlling usually cameras to move them around. It could just as easily control a antenna for azimuth and elevation. And then there's the Sense Hat, which is, I guess, a little similar to that Arduino one. This one was actually developed and used on the space station. And it's a combination of, has accelerometers, a gyro, a LED matrix display on it, a bunch of things, and they did experiments with them. They called it, and it was in a specially made box. They call it the Astro Pi. Then we have the BeagleBone family, which I was more familiar with. Use these to do CNC controllers. And this is essentially a single board computer. The basic difference is it's more oriented towards hardware control, and it's a multiprocessor. It has two real-time programmable processor units that run at 200 megahertz, independent of the main processor. So those can be set up to generate waveforms. In the case of CNC control, to drive stepper motors. So you can generate the 1 microsecond pulses and direction controls, and read encoders, things like that. I've had one of these running 4 axes and 2 encoders, and there was some other stuff. Didn't miss a beat, could run about 100 inches per second cutting. Which always scared me. The family for BeagleBone, the first one was the BeagleBone Black. Then they added, of course, everybody has to be green, so they've got a BeagleBone Green. The main difference, I think, on the green was it included Grove connectors. And Grove is this sort of, and you can actually get Grove sensors for most of these families. And it's a kind of a standardized set of sensors, smoke sensors, temperature sensors, all kinds of gas and output things, relays, all that kind of stuff. And they all use a common, I think it's a 4-pin interface, what they call a Grove interface. So you can get a board, or in case of the green, it's got some connectors on it, and just plug these sensors in directly and program them. The latest one, which I have not actually had, is this BeagleBone AI64, which is a dual processor. It looks like it's extremely powerful. And of course, they call their add-on board something else called Capes. That came from the Beagle, which is Peanuts. What's the dog's name?
Snoopy. The dog's name in Peanuts is Snoopy.
Snoopy, yeah.
Yeah.
And Snoopy wore a cape. So in this case, the Beagle bone has capes. And there's a calm one, there's one that do motors and solenoids and relays. There's it's like the others, there's a cape to do just about anything you want. Okay, so let's talk a little bit about Raspberry Pis. It's probably the more popular one nowadays, particularly with ham radio, and there's even books on Raspberry Pi for ham radio with a lot of applications and things. And with a Raspberry, the first thing you need is to install the operating system, which will be on a little micro SD card. So there's different ways to download that and install it on the card. And then you just plug it into the Raspberry Pi, power it up, and you're off and running. Huh?
And it's supposed to work.
And it's supposed to work, and usually does. We'll talk a little bit about Linux, Python, and GPIO. So Raspbian is just the version of Debian, which is a version of Linux, which, if you're not familiar, Linux is an operating system similar to Unix, but Unix was, I shouldn't say proprietary, it's not free. And Bell Labs developed it, gave it to universities where they distributed some versions, the Berkeley version, for instance. There was a guy, Linus Torvalds, which where it was named after, who wrote the operating system based on Unix, but without using Unix source code. So this is open source code. And it's maintained by a group, and people are free to add extensions and things to it. The only restriction is you have anything you add to it has to be open source. So somebody else could come in and modify it or whatever and use it. So when it's specifically compiled to run on the Raspberry Pi, it gets called Raspbian, but it's really the Debian version of Linux. And there's a number of different variations. There's Ubuntu and Red Hat and Fedora, and I don't remember them all now. I haven't played with that stuff for a while. So we download the operating system from raspberrypi.com. They will run, most of these will run, except for the Pico, will run 64-bit versions of the OS. In some cases, there's, for the larger processors like the Pi 5 and 4, there's a desktop version or a desktop plus, as opposed to a light. If you're just doing something embedded where you don't need to use it as a full-blown computer. You take an imaging program. This Balena Etcher is probably the most popular one. It's another free program, and it will let you put the operating system image onto an SD card. There's SD card formatter. If you're using a used SD card, you want to reformat it. This is a much better way to do it than using the Windows SD formatter. and it's also another free one. I talked about the 400. This is the Pi 400. So, like I said, all you need is to plug in a mouse and a display. You got a complete computer. And it sells for like $100.
And they're pretty fast.
Yeah, it's just about the same speed as the Raspberry Pi 4. I haven't seen where I would imagine they're going to come out with the Raspberry Pi version, like Pi 500 for this, but I haven't seen anything yet.
I've seen, I don't use that, but I've seen people have one running, a version of Windows or an equivalent of
Yeah.
Windows. I don't know what it was, operating system. Couldn't tell the difference.
There are some emulators where you can run DOS on them.
Yeah,
I wouldn't be surprised, particularly on a 5 or a 4, that you could run a Windows emulator. I've never done it. I've gone the other way. Virtual machines on Windows running
right.
Linux. Oh, and this little board in the picture is the Astro Hat that I mentioned before. It has this LED display and the gyros and accelerometers and all that stuff, and it's a very small board. I should have brought one of those. Okay. When you power your Raspberry Pi up, if it's one of the larger ones like the 400 or a Pi 4 or 5, this is a typical screen you're going to see. I mean, it looks just like Windows, works like Windows. I mean, it's a graphical. You do all the stuff, pull down menus, and
That's probably what I saw.
could be. If you can manipulate Windows, you can manipulate the graphical interface for Linux. Which, by the way, Apple and Microsoft both stole the windowing environment from Xerox, who developed X Windows and the whole graphical display, and never. I don't know. I guess they didn't patent it, but it was open.
They sold it to Apple.
Okay. Well, now how would Windows get it? Microsoft.
New code.
Yeah, right. Okay. So this is just another thing on going through the steps on how to install Raspbian on there. And once you had it installed and booted up, the previous screen was what you would see, something like that. The only other step is when you install the OS on the SD card, you can go in and edit a file called config.txt, which is in the boot sector that you can get to when it's plugged into a Windows machine, and modify some of the boot settings. In most cases, you don't need to, but there's a couple in there that, depending on what you want to do, you might need to change. But that's how you set it up for things like if you had, and now they're making a solid state memory board or hat for the Raspberry that you can actually add a solid state drive to it in place of the SD card and run off of a very fast solid state drive.
In that config.txt, would you have the ability in there to put in Wi-Fi credentials?
Yes. Part of that, which isn't shown, is the Wi-Fi setup, which is one thing you might need to go change.
Yeah.
I can't remember what the default is. I think in it defaults to just searching,
Mhm.
but if you have a specific Wi-Fi SSID and password, you can put that in. Okay, so we hook it up. Now, when we bring it up,
This trips people up, they can put in their own personal ID and password, and then they forget it.
has a default ID and password, which the ID is PI, and the password is Raspberry. And as far as I know, it's still that for the defaults. You might, depending on, your application, you might want to go in and change that after you played with it a little bit, when you're confident that you're going to remember the ID and password, because if you forget it, you're going to go back and erase your SD card and reload the operating system and do it over. Instead of the GUI interface, or the graphical user interface, which is what GUI stands for, you can also bring up terminal mode, where you can actually interact with the operating system itself. And this is just some of the basic Linux commands. They're the same thing in Unix. It's essentially an open source copy of Unix. So the most common one is an ls command, which stands for list short, which will give you a listing of files in the current directory. And it's short because it doesn't give you all the attributes, like the permissions and things. If you do a list long, which is an ls space -l, it says, give me the long list, and it will list out the permissions and other attributes for each of the files. The equivalent in Windows or DOS would be a dir. I don't remember there's an option for a short or long version of dir.
C, I think it was, or something. C drive or D
Right.
drive or.
Right. And you can do that same stuff with this, referencing the drive or the directory. CD is the same, which is change directory. Okay. Make dir is the same as it is in DOS, for make a new directory. There's also an rmdir for remove a directory. The move command, which Windows and DOS doesn't have, is very powerful, and it lets you move files from one place to another. There's a copy command just to copy a file. There's remove, which instead of delete, we call it remove. It removes or deletes a file. Then there's sudo, which is super user do, which allows you to operate as the super user or root, which in the Windows world would be administrator. And in the Linux world, we call it super user or root. And when you're in super user mode, I can't think of that's bad when you get old.
I don't know.
The prompt that you're going to see will say root as opposed to whatever user and directory you're in. And you use this a lot to do things like install programs. You would do a sudo to give you permission as root temporarily. And something like apt install whatever the name of the program is, and it would go out and look through your repository directory to find where that program is, download it and install it, or update it or upgrade it, depending on what you're doing. There's also a cat command, which is another one that you don't see in the Windows world. And this will just list out a file. There's a few others that you don't use as often. And one of the neat things about Linux or Unix is you can kind of cobble all these things together with pipe commands where you can have the output of one of these go into the input of another one and sort of daisy chain a long string of commands and do some really powerful stuff, which you can't really do in the DOS or Windows terminal type mode. Okay. One of the more popular programming languages that you'll see, and this is true even in the Windows world, and a lot of the amateur radio applications tend to be done in Python nowadays. It's an interpretive programming language. It's kind of like, let's say, a very advanced version of BASIC, much more powerful. In some ways, it's looks a little bit like C. You have all the standard conditionals. You can do for loops, while loops, if, then, else, which basically almost every programming language has those
Those commands.
yeah, I was thinking there's another word, but yeah, those commands. The print command gets used a lot, and it allows you to print out text and or values, and you can do arithmetic within the print command. Hopefully I have an example of that here if we can fire this thing up. The import command allows you to load libraries that you can use in your program. One of the probably more popular ones is the machine library, which allows you to manipulate the general purpose IO pins on the processor. In other words, control those pins as digital in or digital out or analog in or analog out. And then you have your for loops, while loops, conditional ifs. So you've got if a condition such and such or else you do something else. There's an input command which lets you kind of the opposite of print, lets you read a keyboard input so you can have an interactive program. So with just those fundamentals, you can do some fairly powerful little programs. This is showing one of the menus when you bring up Raspbian. And if you go to the Raspberry, which is the main menu, and under that would be programming, and under that are all these, and most of these things are installed by default. One of them is Python 3, and it says idle, which is the, I think what this stands for, interactive development learning environment or something like that. It's just a programming suite, I should say. And that's we're up to Python 3. You can still do old Python 2 if you have older programs that aren't compatible. There's also And it won't show up, I guess, on the regular Pis, but for things like the Pico, we have what's called MicroPython, which is a scaled down version of the Python language, which actually runs and is embedded on the Pico itself. So you can you just download the program to it and execute it. And I'll try to do a demo of that. We talked about GPIO, and most of the Raspberry Pis, in fact, I guess all of them, have a 40-pin I/O connector. And this is what the pinout looks like for most of them. In a lot of cases, you can have more than one function on a pin. So you can program whether that's going to be a GPIO pin, which is general purpose I/O, or let's see, what is an SDA? That's part of the serial interface. These are more serials down here, the SPIOs. Oh, wait a minute. Maybe that's a digital analog converter, maybe. I don't remember. Mostly we're going to talk about the GPIO. It does have one here as a pulse width modulation output.
You don't want to go too.
Yeah,
Well, then
lots of stuff. Yeah. Now, in this case, there's really, in most of them, you only see like two options for the function. On the BeagleBone, it's as many as 4 or 5. You have this device tree that you have to load to specify what function is mapped to what pin. It's a little easier to do it in the Raspberry. So MicroPython is a scaled down version of Python specifically to run on the Raspberry Pico. And there's an IDE, an integrated development environment called Thonny. Not sure how they came up with that, other than it's kind of rhymes with Python. And it lets you load the programs and edit them and run either on the PC or on the Pico. You can run them on the PC in the Thonny environment without even having the Pico attached. One of the things most programmers do for a new thing is what's called a hello world program. And in some languages, it's very simple. In other languages, like Ada, it's very complicated. This is one of the simpler ones where all you do is say print. And because you want to print out text, you would put it in quotation marks to tell it it's text. And when you execute it, it's going to print out what's in between the quotation marks. Here's an example of how we would program one of the GPIO pins. And in this case, we're using the machine library, which we had to have already imported. And we're going to use the pin function out of that library. So we'd set up variable X is equal to machine.pin. And then within these parentheses, we say it's pin 15, that's GPIO 15. And we set it as an output. In this case, we set Y equal to GPIO pin 0. We set that to an input. So now we can use those two pins and write directly to them as inputs and outputs. So it's actually fairly easy to do. Oh. In the Pico, we have more options per pin with UARTs and all kinds of serial and stuff. The green ones in the first rows are all the GPIOs, which is what we really care about at this point. This is the typical breadboard for similar to what I have here for a Pico with an LED hooked up to, I believe this is GPIO pin 15. I have to go look at the map. So it's just a resistor in series with the LED back to this pin over here, which is probably 5 volts. Or it could be ground in this, I don't know which way it's going. And I can't tell. So in order to, yeah, that's supposed to be pin 15 where it's shown. In order to make that LED blink, we need a little program like this where we import the machine library. We import the time library because we want to have a delay. We define the LED as we call it LED external. And we set that to GPIO pin 15 as an output. We create a loop and say while true, which means it's going to loop forever because there's nothing to ever make it false. We're going to toggle that LED off and on. And after we toggle it, we're going to sleep for 1 second. Go back through the loop, toggle it, sleep for a second. So it should blink the light 1 second on, 1 second off, 1 second on. So we've just generated a square wave driving an LED. So hopefully let's see. I can stop recording.